All right, stat students. So we have a very quick video today about interpreting confidence intervals. The next video lessons, I've got to create two of them because there's going to be a split in the way that AP does things and the way that dual credit does things. Okay. So this video, it's going to be simple, short. We will work a couple questions in the problem set, which has not gone up on Kitim yet. I'm so sorry. There's so much going on that it's something that I just keep putting on the end of the to-do list, but it will go up there. Okay. So let's go ahead and get into it. All right. So in your notes, we're going to write down these two statements here. And in your notes, you can draw a line for me. Okay. Draw a line for me. So when we're interpreting confidence levels and confidence intervals, and by the way, for AP students, this is extremely important that you have these statements memorized. Dual credit, you'll need it for multiple choice style questions, of course, and knowing how to interpret those questions. But I'm going to pause the video and let you guys copy this down in your notes. You can sort of write interpreting confidence intervals, and then you have interpreting confidence levels. You're writing these two quotes. Okay, these are very important quotes that you'll be using as your templates for creating confidence intervals. So I'm going to pause and let you write that. Okay, so you've had time to write this. Now let's go ahead and put this into action. So yesterday we had these confidence intervals, and I'm going to go ahead and start a new page with these. Let's these onto a new document. Paste. Okay, so there's our confidence levels from the other day. So if we want to interpret I'm going to write this. So we're going to say interpret the 95% confidence interval. Okay, that's what we want to do. So we go to our template, this right here. Okay, we're going to interpret the interval, and you are literally going to, and you're going to write this in your notes next to where you wrote these intervals, and or you can do it with our example for Mr. Mean. You can write it right below this. So say example Mr. Mean in your notes. We want to interpret that interval for the 95%. So we are going to word for word copy this, and I'll type it slowly as you write it in your notes. We can just sort of practice doing that interpretation. Okay, so I'm going to put in quotes. We are, it says C%. Well, what percent are we? Well, it's going to be 95% confident that the interval from, and you have, it says blank to blank. Well, we have that right here. We're looking at our 95% interval. We're going to go with from 302.65 to 322.65 captures the actual value of the, and now in the brackets it says population parameter in context. So what is the parameter that we're trying to guess? Well, we wanted to find the mystery mean, the value of the mystery mean. There's our statement. That's all we have to do for this one. It says to interpret. So AP students, if you have especially free response, it says be sure to interpret this confidence interval. This is the statement that you're going back to. So guarantee on the next test, I'm going to ask you to interpret a confidence interval. So you have to remember all these parts. Remember that the goal of a confidence interval is to capture or predict, help predict the true mystery mean. Just like Lunchbox was trying to predict the weights of the callers, that's what these intervals are doing. They're trying to find what's unknown, that true parameter. Okay. Now, let's interpret confidence level. So there's probably still a mystery what exactly confidence level is. There is a difference between these. Okay. So in here it says, it has the quote. It says, if we take many samples of the same size population. Okay, that means we're making a sampling distribution, right? And we talked about that with the calculator, and I pulled up and made a sampling distribution, right? If we'd taking many samples of size 16 from the population, it was creating a sampling distribution, okay? But we only did one. So if we take many samples of the same size from the population, about C%, well, we're saying 95% of them will result in an interval that captures the actual parameter value. Now this parameter value, we're going to say, we're actually going to change that to mystery mean, right? That's our parameter in context again. Okay, so I'm going to go ahead and replace that there. That's going to be the interpretation, and I need to move my camera up, hold on. It's going to be our interpretation of a confidence level, okay? So just to give a little bit of a visual to go with this, I'm going to show you guys an applet that's going to help visualize what a confidence interval is. So one second, let me pull that up. Okay, so I have this applet, and this is the same website where I did the Reese's Pieces. Rossmann Chance is what it's called. And we're going to simulate confidence intervals, and we're going to do the exact same simulation of our example with the mystery mean. So first thing here, we have to change it from proportions to means. We've always talked about, in this chapter, we're going to have p hat and x bar, okay? But we're talking about means. What is the mystery mean? Well, we can type in whatever we want. Well, what was our mystery mean? If I go back to the calculator, it was 322, right? So let's go back here. We're going to put 322. We know that our standard deviation was 20, and we're going to take a sample of size 16, okay? And we're going to start by, we're going to make a 68% confidence interval, okay? And by the definition here of, let me move this over. By the definition of confidence level, if we're at 68%, we expect C% of these intervals will capture this actual mystery mean. So let's go ahead and sample. So this black line represents the mean, okay? And this interval here, which I can zoom in, interval, this green line means that's the interval, that's the lower to upper boundary, all right, is actually capturing it. Over here, we actually see the sample. Here's the mean, 321. So it was almost dead on. It was almost a perfect estimator. You can see the standard deviation changed. Here's our, so we have all these stats here. So all of it contains it. So let's do it again. That one did not contain it. That's sort of like our example. This one was 328. Our 68% did fail, right? If we keep going, sample, 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 okay? 68% of these samples is, by that rule, the confidence level, what that means is 68% of them should capture the mean, okay? So if I did 100 intervals instead, because we're only ever going to just do one of them. If we do 100, then we just have a sampling distribution, and we can predict it by using the sampling distribution. But let's do 100. So we're going to see 100 lines stacked here. How many do we expect to contain or to cross this line here? Well, you should be thinking, oh, it's 68, right? So let's go ahead and do that. And you can see here, 72%. Look at all these lines. So that the red, there's 32 of them. Let's go again. We're looking for, or excuse me, there's 28 of the red ones. Let's do it again. That's 65. So we have 35 red. So on and so forth. So that one's the closest one. And if we add more samples, let's do 1,000 sample. We're getting closer, right? Because this method should yield by that process of up and down. it should yield it. Now I do want you to check this out. What we have here, this is the most recent sample. This is a sampling distribution over here. And you'll notice, look at that green. Now, this, by the rules for normal distributions, which by the way, this isn't normal. Why is it not? Oh, actually, it is approximately normal because we know the population is normal, right? But you'll notice that that's one deviation, about one deviation above or below the mean, okay? 68% of the data should be in there by our rules. It's all coming together here. Let's do 10,000. Our distribution, it's almost a perfect, I mean, it practically is perfectly normal, right? This is quite intense to look at here, but you'll see it's almost perfectly 68% of these intervals, okay? Let's dial that back a little bit. Go back to 100. Okay, so what is going to happen if I increase this to 95%? Well, how did that change our intervals here, right? Well, the only thing that changed was the critical value. So increasing the confidence level changes the critical value, which does what to this interval? Well, you'll notice that we were able to capture it when we went to 95% because it widened that interval. And you can see the direct connection like out through arithmetic here. You can see it's because this number got larger. So when I change this on here, it's now 95%. This is 68%. What we're going to see, and maybe you can predict what's going to happen, it's going to get wider. Watch these intervals increase. You're increasing them by adding another one of those standard deviations. We're going from one deviation to two deviations. So you'll even notice that here, how there's going to be more green in this sampling distribution. Green means it captured it, red means it didn't. So let's go ahead and look at that. Yeah, and you'll notice here's 89%. So that one was a little bit lower, but it's not going to be perfect every time. There's 93% majority there, okay? But let's do 1,000, and let's actually go ahead and do 10,000, and you're going to watch this sampling distribution. You're going to see it's going to be a normal, and compared to the 68%, we're going to say 95%. So it's relating directly to that distribution. Look at that. Almost pretty exactly 95%. Now they're rounding just a little bit here, but almost perfect, right? That normal curve. 2 deviations of that normal distribution, right? So we feel very confident that it's going to be in there somewhere, that true mystery mean, which the mean of the sampling distribution is practically exactly equal to this if you're comparing this number to the one that we have here. What happens when we go, let me backtrack this a little bit, we'll do 1,000. Let's go back to 100. What happens when we get to 99.7? This would be a critical value of 3. Well, it's going to get even wider and more likely to do this. Watch these increase in width. They went up, and we didn't have a single one fail. And it'd be hard to actually find one that's going to fail. No failures. There's one failure, finally. That brings it down to 99%. But it's very unlikely that you'll have a failure in your sample. What happens when we go to 99.9%? Well, these get not much wider, but decently wide, right? 9999. These are going to get a lot wider. Okay, practically filling up the whole thing. We're probably not going to find one that fails at this point. But this is sort of like me saying, when I guessed the weight of the student, I said, hey, your weight is going to be between 0 and 300 pounds. Am I correct? Yeah, of course I'm correct. I would be 100% confident. That's because the way that we're constructing these, I'm never going to miss. So watch what happens when I make it 100%. Essentially, this should go on forever, right? This should be negative infinity to infinity. It's not going to do that, but we don't have a z-score for this. Like, it's filling up practically the whole thing. These are never going to fail. It's just not possible. The way that these samples work, it's never going to fail. That's what's happening. Think about confidence level as the number of deviations from the mean as a percent, right? When we're 68%, we are one deviation. So in this histogram or this plot here, we're one deviation. So we go ahead and sample. So 68% is that middle 68%, 95, and we'll go to 1,000 here. That middle 68%, then we go to 95%. Sample. 2 deviations, right? 99.7. practically everything, right? We have a few failures here, not many. And you'll see, hey, look at that. It actually, we had three failures. Yeah, 3 failures in 1,000. Pretty amazing. Do another sample. Okay, we had more failures there and sort of on both ends, but that's 3 deviations. It's very rare to be outside of 3 deviations, right? If we do 100%, oh, my camera, I'm on the wrong screen. 100%, it's just not going to happen. Man, it's completely a solid wall here. Every dot, by the way, represents a sample. Those are shown here. They're stacked up. So this is a really cool applet to give you an idea about how sampling distributions are affected, or are created, right? There's a few more rules that we're going to talk about here with this simulation. I'm also going to link this just in case you want to play around with it with some of these values and maybe get a better understanding, just for those that are curious about it. But hopefully this is is helpful. Okay, so now we can answer a few questions on here. Okay. You should be able to answer most of the front. Those questions are quite complicated. You're having to use the interpretations and those definitions to help you with these. Okay. So those are up on Delta Math now, so you get 3 tries. Okay. If you miss twice, you can of course reach out to me. But using your definitions, hopefully you're able to narrow that down. But I want to talk about number 5 here, and then I want to talk about number 7. Then we're going to stop the video. Okay. So number 5, it says use the scenario 8.1 to help you with it. Okay, so it says a Gallup poll found that 47% of adults 18 years old or older in the United States felt that a third political party is needed to represent the American people. In the description of methods, the poll taker said, for the results based on the total sample of national students, one can say with 95% confidence that the maximum margin of sampling error is plus or minus 3 percentage points. Okay, so here it says use the scenario. The term 95% confident means what? So what is it? Basically, this is asking about confidence level, right? Or how? No, this is asking about the confidence interval. Okay. So I'm going to pause, and I want you guys to see if you can get the right answer here, A, B, C, D, E, and see if you can get it right. Okay. So let's go ahead and talk about this. The best answer for this would be C. Okay? Talk about that. Talk about C. Okay? Let's actually talk about why the other answers are not correct. When we're talking about a confidence interval, this is only giving us 47%. We're never going to be confident in one value. We want to be confident about an interval of values. So B could not be it. Okay? I had a student say that they thought it was D, but here's the difference between those. All Americans versus the people interviewed. The people interviewed implies that this is talking about the sample. Confidence intervals are not interested in samples, right? If we go back to our definition right here, we're interested in capturing the true population parameter, or we did mystery mean, right? Here they're interested in the population proportion, right? We're talking about percents. So that's the difference here between those answers. We're interested in the percentages. So it wasn't this one. Here, this 93% and 97%, we're never actually making an interval with the confidence level. Confidence level is, once it's chosen by a problem, you're sticking with that the whole time, okay? It does say in our bullet points that the user gets to choose the confidence level right here. Usually that means the problem's going to pick the confidence level. In real life, you would be able to choose your own confidence level. Typically 95% is going to be used. But there's going to be a lot of problems with other confidence levels that we'll have to use, and we're going to talk about that in the next lesson when you're doing calculations. And I've got to split that up for dual credit and AP. Okay. Let's go back to the problem here. So this isn't it. And then the difference between A and C, they are kind of saying the same thing. They both say all Americans, right? But we don't use the term when we're going with our interval here. we are C% confident that the interval from here to here. So we always need to include, when we're doing our interpretation, that actual confidence level. So that's why C is the best choice on there. Okay. So let's talk about 7. It says the critical value used to construct a confidence interval for a proportion depends on what? So how do we determine the critical value? Well, that's in our notes here as well. Critical value depends on the confidence level and the sampling distribution of the statistic. And really, more importantly, this is what we have here. This is going to be our answer to this problem. Okay? All right. Only on the confidence level. Honestly, I would actually take this out. All right. That's the most important part, is confidence level. Because if we're 68% confident, that's a critical value of 1. If we're 95% confident, critical value of 2. 99.7%, we're critical value of 3. That's going off of that normal distribution. Okay. So that's the main idea with those. All right. Oh wait, I'm on the wrong thing. So the best choice for 7 is going to be E. Okay, I'm stopping my lesson there. I said it was going to be shorter. We're about 10 minutes shorter than the others, so that's pretty good for me. If you have any questions, let me know.